Welcome to the talk entitled Mathematics Concept Inventories and Conceptual Capabilities for ITE Students. The abstract name for this presentation, we're going to focus on research question 2. How is the concept of learning gains best described mathematically and implemented in adaptive testing? Research question 1 is some other work we're also trying to attempt, which is looking into how well and how often concept inventories have been used in terms of a systematic review. The last point at the end is something that is looking at future work. So we really want to assess ITE students in a more efficient manner that leads to less stress and extra time to perform other things such as surveys on self-efficacy. Why is conceptual understanding important? I think anyone who works in education and social sciences understands that the big ideas are really important in subjects such as STEM. In mathematics, in my own opinion, this is sometimes the letter that is left out from the STEM, whereas the M in STEM. Although some people have argued statistics is one of those threads that weaves through the STEM subjects. Concept inventories in general, CIs, usually have a pre and a post test and can be used to measure something called conceptual gain. An example of that would be the force concept inventory, which is used in physics and has been used for the last 30 years or so and is well understood in terms of questions that possibly have biases and other issues, but it has been thoroughly investigated and researched. The calculus concept inventory, on the other hand, is less well known but has had some research investigations. There are other types of mathematics concept inventory and they are also worthy of study. The reason we would have a concept inventory is because we would like to perform some kind of intervention, such as peer-based learning or interactive engagement. But the CIs, these concept inventories, take time, so we want to try and reduce the amount of time taken. This is Physport. If you are not aware of this, and you may well be, this is where many of the force concept inventories can be found in physics, such as the FCI and also the calculus concept inventory. So I do invite you to register and have a look through the resources there. What are concept inventories? Well, essentially they're a psychometric test that understands or considers conceptual understanding. Prime examples would be the FCI and CCI that I just alluded to. The pre-test would be given at the start of the course, and this is compared to a post-test at the end of the course. Of course, for something like the the force concept inventory, students are coming in from high school who have already studied physics. However, that doesn't stop you giving that pre-test and comparing it to the post-test. Usually 30 questions, such as the FCI. The CCI, for example, is about 21 questions, and it usually takes 30 minutes. However, students and LICs really don't like to have to use this extra time, and that's one of the issues that we're trying to address here. Just in terms of some mathematics, it's not just about gain. Here's the Hark gain, based on the work by Hark et al., which is the classic normalized gain that's used very commonly in various subjects such as physics and mathematics, where you compare the post-score average of the class or a cohort to the pre-score average, and you normalize it by dividing by 100 minus the original pre-test score. There are issues with this, which you can look into in the literature, or we can discuss at the end. One other approach is Cohen's effect size, which is similar and also possibly has issues. However, there has been some research done using the Rasch model and its related cousin item response theory, which gives a mathematically consistent definition of gain. Actually, this formula does not really work, but we'll go into reasons for that later. In terms of item response theory or the Rasch model, the simplest two-parameter version has what we know is known as a difficulty parameter for each question and an ability parameter for each student. That's the key to how we might be able to speed up for example, the force concept inventory. There is another method which we've also used, which is the method of dominant misconceptions, which doesn't really require you to use any of these resource-intensive procedures. So, computerized adaptive testing, CAT, NAPLAN, if you go to their website, appears to have been using some form of computerized adaptive testing. MathSpace, which as a former physics and maths teacher in high school, I've used MathSpace, and their website alludes to some type of adaptive learning. Whether it's using something like item response theory, I think it would be a good idea if it did. And where we're trying to follow on from is the work of Yasuda et al., which developed computerized adaptive testing, CAT, for the FCI. So how can we speed up concept inventories in general? Well, if we use item response theory, we can then measure the difficulty parameter for each question. If we've given, say, 1,000 students this test, then we should be able to extract those parameters. And then if we have a new student who sits the test, hopefully after several questions, for example, if the student is competent, they may choose question 1 to be correct, and they moved on to a slightly more difficult question. And likewise, if the student struggles with the first question, then they will take a set of easier questions. So this should hopefully speed up the test that you're looking at. For example, the force concept inventory may be done in half the time. So we hope with CAT that we can have the following: less anxiety in conceptual testing. I think everyone realizes that students, particularly nowadays, high school students, initial teacher education students, students at universities, have anxiety. And we've seen this from studies on the FCI time taken to complete, and also unanswered question rates from a study in South Africa. It shows that there's a lot of student apathy towards the end of the test. So if we can shorten that test, they never really get to what would have been the end. And this will give more time for student surveys in relation to, say, their self-efficacy or self-determination theory, and give you more time for interventions. And as I alluded to, we are trying to investigate how a maths concept inventory could be applied to ITE students. For example, primary school ITE students, what kind of test could we give them? Here's the selected references, and I look forward to chatting with you after this video recording. Thank you.